Yep. Yeah, it goes position, velocity, and then acceleration. Right. And to work your way down, you have to take a derivative, and to work your way up, you have to integrate. Right. No, it's just motion stuff that we talked about on Friday. So if you want to go from position to velocity, you take a derivative. Or velocity to acceleration, you take the derivative. If you want to go from acceleration to velocity, you integrate. Or velocity to position, you integrate. So derivative to go down, integral to go up. Alright, so a particle moves along a straight line. For t from 0 to 5, the velocity is given by, and then they give you the velocity equation. Hey, what's up? Hopefully Wednesday. Yeah, probably.
I wonder if I let Shannon pick them up tomorrow, then I can bring them in to you.
Yeah.
On Wednesday.
Yeah, maybe so.
I'll email her.
Because they have 2 sets, so even if somebody else is using them.
I'll email her and see if she'll have them right.
Okay. And the position of the particle is given by, they're using s of t instead of x of t. And it's known that s of 0 is n. So find all values of t in the interval 2 to 4 for which the speed of the particle is 2. That's the absolute value of velocity. So they want you to figure out when is the absolute value of velocity equal to 2. Right. So what you can do is you can graph the absolute value of velocity and the line y equals 2 and look for where they intersect on the calculator. Right. And you want to make sure that you only look at the interval from 2 to 4. So we only want to give times from 2 to 4. So we're going to learn how to do this in the calculator. So we are going to turn on our calculators. Alright, we're going to go to the graph. If you have stuff in your graph, you can clear it if you press menu and then number 1 actions and delete all. So when you're on the graph screen, if you do menu actions and delete all, it'll delete everything that's in there. And then if you want to reset your window, if you go to menu and window, you can choose zoom standard. We're going to change the window in a minute anyways because we only want to look from 2 to 4. But if you want to get back to a normal window, you can just go to zoom standard. Alright, so we're going to press tab. I'm going to type in the absolute value. So absolute value, remember there's a template for it. It's the template key. It's the first template on the second row. The absolute value of negative 2 plus parentheses x squared plus 3x close parentheses to the 6 over 5 minus x cubed. Right. So we're going to graph that. That's the absolute value of the velocity equation. And then I'm going to press tab again and I'm going to graph just 2. And I'm going to change my window so that I'm only looking from 2 to 4 because right now there's several points where they cross, but I don't want to find all of them. I only want to find the ones that are in the window that I want. So I'm going to go to menu, window, and window settings. And I'm going to change my x to go from 2 to 4. The rest of it doesn't matter, like the scale and y's and all that. You don't have to worry about that. You just want to make sure you set your x's. So really we just want these 2 points where these cross. Right. Up to x. Is that what you're talking? Yeah, I just use x instead of d. Right. So you put in the absolute value of velocity, because we're trying to figure out when is the absolute value of velocity equal to 2. And we don't want to try to solve that equation by hand. So to solve an equation in the calculator, just graph both sides of the equation and look for where those 2 cross. So we put one side into y1 or f1, we put the other side into f2, and now we can look and see where they cross. So to do that, you'll press menu, analyze graph, and intersection. And then it's just like when we were finding zeros with the calculator the other day. You just move that little dotted line that pops up to the left of your first point of intersection, and then you click the little click pad, and then you move it to the right. So t equals 3.128 or 3.127 would be this one. And then you just, on what? On what?
When you click F1 and F2, after that, make it do the graph.
And then change the window. Is that what you're talking about? So go to menu, window, and number 1, window settings. And then we want to set the X just to go from 2 to 4. Because in part A it told you just from 2 to 4. Yep. So to find these points of intersection, you press menu, analyze graph, and intersection. And then when this little dotted line pops up and it says lower bound in the corner, you're going to put that to the left of the point of intersection that you're trying to find. Anywhere to the left, it doesn't matter. You just want to put it somewhere to the left of that point of intersection. And then you just click the little click pad. And it should change to upper bound. And then you just slide that to the right until you can see that point of intersection. And you click again. Now mine are kind of overlapped, kind of hard for me to see the text here. So if you just hover the little hand over one of the points and then click and hold, it will grab that, the hand will close, and then you can move it. So I can see it's 3.473. So 3.128 and 3.473. Let me see. So to get it to go more decimal places, hover over the ordered pair and then press Control Menu. And where it says attributes, you can change the very first one is the precision. So you can change how many decimal places it shows. So it's Control Menu and then attributes. Alright, so this was worth 2 points out of the 9 possible points on this question. You get a point for, and notice I did write that I was finding where the absolute value of V of t was 2. So they do want to see that that's what you were doing. And then a point for the answer. So if you just wrote the 2 times, you'd get that point. So it's a good idea to just write down everything. Even when you're using the calculator, write down what it was you were using the calculator to do. We were using it to find when the absolute value of velocity was equal to 2. All right. All right, so part B, write an expression involving an integral that gives the position. And then use this expression to find the position of the particle at time t equals 5. All right, so we know that the initial position, right, where the particle starts, is at 10. Right? This says that the position when t is 0 is 10. So if we want to know the position at some other time, to find the change in position, you integrate the velocity from the time that you knew the position, so we knew the position at 0, to some other time, right? Some other time that we would want to know the position at. Right? So the initial position plus the change in position. Change in position, if you integrate velocity from the time that you knew the position to whatever new time you want to know the position for. So this would be the integral that gives the position. And so then we can use that by integrating from 0 to 5, the velocity equation. All right, so you can do this in a calculator. All right. So I go to the calculator. I can type in 10 plus menu calculus numerical integral, or there's a template for the integral, from 0 to 5 of -2 plus, and you can do t or x here. On the graph you need to use x. On here you can use t or x, so t squared plus 3t to the 6 over 5 minus t cubed dt. So the initial position plus, and then if we integrate from 0 to 5, that'll give us the change in position from 0 to 5. -9.207. So that means after 5 units of time, whatever they were, seconds, minutes, whatever, the particle would be at -9.207. So I think this is also 2 points. I think it's a point for the integral and a point for the answer. So, yeah. So we have the integral for the position, and then s of -9.207. So 1 point for the integral and 1 point for finding the value.
Would you find that second part be sufficient to get 1 point, or would we just have to write the general equation above?
I think you'd have to write the general equation. Yeah. All right, part C. Find all times t in the interval 0 to 5 at which the particle changes direction. Justify your answer. So a particle changes direction any time that its velocity changes signs. So what we're going to do is graph the velocity function and look for where it crosses the x-axis, because those will be the places that it changes signs. So, and we'll just look from 0 to 5, right? The interval that we want to look at is from 0 to 5. So if I go back to my graph, I'm going to delete all of this. And then I'm going to type in my velocity equation using x instead of c. So -2 plus x squared plus 3x to the 6 over 5 minus x cubed. I'm going to change my window back to 0 to 5. So everywhere that it crosses the x-axis, the velocity is changing signs. It's changing from negative to positive here, which means it's changing from moving left to moving right. And then it changes again here. It changes from positive to negative, which means it changes from moving right to moving left. The sign of the velocity determines the direction that it's moving. So if we're looking for where it changes direction, we're looking for where it changes sign. So here we would want to find the zeros. So if we go to menu and analyze graph, this time we're going to do number 1, the 0. But other than that, you do the exact same thing. You move that little line to the left of the first 0 when it says lower bound, and you click. Then you move it to the right of the first 0 when it says upper bound, and you click. So 0.536. Okay, hold on, I'll come back. And then the other one would be 3.318.